Hi, I'm Pete, and this is an introduction to Favor.js. Favor is a JavaScript node library that makes it easy to interact with hardware devices, and this actually runs on the device. So the reason for Favor, the reason I created it, was I didn't like that we hard-coded so much information into our C programs and other programs that we use on devices. And I wanted to create something that was a more consistent interface for running our business logic on different types of devices using different hardware. And I'll show you how that works now, just using simple LEDs, which is the hello world of hardware. So here I've got a Raspberry Pi. And on the Raspberry Pi, I've got 3 LEDs hooked up, and each of those LEDs uses a different protocol. So normally you would have to write your logic to each one separately, and I'll show you how this works. So here I have included a config file, and that config file will live on the device. We'll get into more of that detail of what is in the config file later. And now I'm just going to include the favor library, and I'm going to pass in my config file. And I'm also going to define a callback, which I'll pass in as well, and I'll just console log the values that are coming out of favor for now. And now I'm going to say LED. So if you're familiar with jQuery, of course, this is very similar. I'm going to say LED. That's going to get all of the LEDs on my device, set to 1, and pass in my callback. And there you go. All 3 of my LEDs have turned on. And you can see there the output was 1 for each LED as well. And if I set that to 0, well, look at that, they all turn off. Turn those on again. And actually, let's do something interesting here. Let's not turn them all on. Let's turn them all off. And I will just turn on the gpio. Oops. No, sorry, set that to 0. Let's set that to 1. And the gpio has all been set on. So as you can see, it makes it really easy to get to different parts of your device. Let's turn everything off. And again, I can LED set. And this time, let's pass in an RGB. And look at that, they all go to red. And of course, I can do the same with green or blue. And it doesn't matter what the hardware is, everything just works. So let's take a quick look at how this works. As I mentioned, I created a config file. Now, what's nice about doing things this way is you're really separating the logic from the hardware. So here's my config file for Hello Worlds. It starts with a name, which is my Hello World LEDs. And I have a path, which is what's used for my I2C, which is this LED here is the I2C LED. And then I list the components. So I have a tricolor gpio LED, which actually has 3 entries here, 1 for each color. I also have an I2C interface, as you can see here, that owns I2C. And I have my SPI. And so for each of these different interfaces, you will define the address that the device can be found on, what its interface is. I2C has an init function that needs to run, so Favor takes care of that when you provide an init function. And with the set, again, you tell it what you need it to do. We needed to write in the set. We need to send this value, and then you can see here I've got a few of these format inputs. Now, if you're only going to pass 1s and 0s into your GPIOs, you don't need to set your format inputs, but we of course did some interesting stuff there. So each one of these you can see has a different function that is called for the format input. And I just define those functions here. And again, it's really quite simple. For the tricolor LED, this is the color that got passed in. If it was a 1, great, no problem, let's return a 1. If it's a 0, return a 0. If it is an array, sorry, I'm just checking if this is an array, and then I set my RGB. And because this GPIO is not pulse width modulated, so it is only digital, it only accepts 0s and 1s, I would just pass 0 and 1 to the return of those red, green, and blue colors. The blink m was really quite simple. Again, if it got a 1, I would return an array which all colors set to 255. If it was 0, set all colors to 0. And if it was an array, I would create the array. And again, the init function that is needed for this blink m I squared c LED is run automatically. And this is my APA 102 LED. So that was the SPI LED here. This one's a bit interesting because if you look down at our code where I define it here, the first thing the LED needs to do each time is get a string, or sorry, a buffer of all zeros, and it wants 32 bits of zeros. So I create one entry that is 32 bits of zeros, and my second entry, I'm going to format the input, and again, it's expecting an array where we have the first value is set to 255, and then for each value beyond that, I've created a separate function to turn these values into hex, and each of those come in the array. And what's really strange about this one is that we started off, rather than a standard red, green, blue, this is actually blue, green, red. So a bit interesting, but all that data comes in the data sheet. And as you can see, we've made it very simple, with not a lot of code really, to interact with a whole bunch of different devices. And if your device only had I2C or only had SPI, this would make it really simple. So that is the first introduction to Favor and working with LEDs. If you have any questions, you can find us on GitHub. I'll just type the address here. It's actually, I should have just opened that in a browser window. It is github.com/favor, and the Favor package is actually currently called IT. So thank you for taking your time. Have a play, let me know what you think, and I'll be doing these updates on a regular basis with new features and new ways of interacting with Favor. I hope you like it. Thanks.